Hello and welcome back. Let's talk about class decorators. Class decorators are applied to classes instead of functions and are defined using a similar syntax as function decorators. Let's take a look at some examples. In this example, I'm just going to write a male decorator, a decorator that defines a male gender. So I'll say male, and then that will take in a class. To the class, I'm going to attach a gender attribute, and then that attribute will take the string male, and then I will return the class. Sorry, CLS. I'm returning this class. So this is the decorator function, and if you remember the way we did decorator, I want to decorate a class called person. I'm just going to say pass. I want to decorate a class called person. If you print out the dunder dict of the person class, you will see all the stuff that are there. To decorate this, I can just put the male decorator in there. And right now you see the property gender is added with the value male because I'm decorating it with the male decorator. So whatever class I add this is going to add a class attribute called gender, and it's going to make it male. Now, the way decorator works is just the same way with the design pattern. We decorate the class. So in another way, we can come and say, let me do it in another way. Let me take these out. Okay, just comment it out. What we do when we decorate is we'll say, let me decorate the person class. So I'm going to say male. The male function takes in a person, right? I'm decorating the male function with a person. This is instead of putting the decorator right here, I'm just showing you how in a simple code, how the decoration is made. So if you print out this P returns a class, it returns the person class. If you do the dunder dict for P, you will see it returns the same thing. It's returning the dictionary for P, which is for person, and it's adding male because I decorated it with a male. Let me do another one and make it female. If I decorate the person class with the female decorator, you'll see it's going to show female. So instead of doing it this way, Python gives us the opportunity to just put the decorator here, female, and of course, P doesn't exist anymore. It is the person class that has the female gender added. Let's return it back to male gender. Let me just take out this now because I don't want to add a male and female decorator. I just want to have a gender decorator. So what I'm going to do is I'm going to right here, you can see the way we created this. I'm going to put all that in another function that I will call gender. I'm going to push this function and then I'm going to say gender type. I'm going to take in the attribute gender type. I'll just change this to wrapper instead of calling it a specific gender. So now I can change the attribute gender to gender type. Now we have a decorator gender that takes in a type. So right here, I'm going to change to gender and then put whatever type I want in the gender decorator. However, I haven't finished this. What you do is now that you have this and it returns a class, you also have to return the wrapper. So now with the wrapper returned, you can see here we have gender receives female and now we have female. If I change it to male, it's that attribute is created and it becomes male. I can also create a method inside the decorated class. Let's say we define a decorator called greetings. It takes in a class. I can add a greet method in there and maybe use an anonymous function, a lambda expression to say the self of the class. And I'm just going to print out hello self. So it's going to return the self of the class. So let's do a class person, do the init the name. If I initialize the person and put a name in there, okay, I'm supposed to return class, and then I add the greeting decorator on the person, and I have instantiated the person. I can call the greet method, because what this does here is create a method called greet. It's as if I did greet self. That's what the self is, and then I returned this. This is exactly what I did using the greet decorator. So I'm just going to take this out. The lambda expression helps me to make a function that is put into the greet. So I can right here call that greet method, which returns the greeting. Yeah, we're not seeing any output here because I need to print that out. So I'm going to print out what is in P. So you can see it says hello self. And of course, I can get what the self is by doing the string method, and then I'll return self.name, which I added. So here is saying hello Matthew. So whatever name you add here, the greet method that is done using the greeting decorator will output hello, the name of the person. Let's take another example. I'm going to write the person class again, define the init the same way I did, and also the string, that is the string. And I'm going to create a decorator. I will just call it decor, and that takes in a class. And I'm going to add a method called say, and that method is a lambda, and the lambda says hello. So this is what we have now. I have to return the class. Every time you call decor on person, it automatically creates a say method. So I can call the person class and print out the say method. Is say self says hello. That is Luke says hello. Whatever name I have here will say hello, because the method is created this way. I want to change whatever is being said. I don't want it to be hello anymore. I want to change it. So this time I want to change this into a parameterized decorator where it can take a parameter. You've seen me do that before, so you can guess. What I'll do is to create another outer, I'll call that word, and then I'll put in the parameter and push this in. So now I have the decorator as word, and it takes in text. And then here, I'm going to just put that text right in here. And after doing that, of course, I will return the decor internal decorator. When I call it here, because it has parameter now, I'm going to say word, and in word, I can put whatever I want to say. So you can see now it has a parameter, and it is taking in the parameter. So you can say Luke says we're going out. So that's because this class now inherits the function, this function, and the function gets its parameter from the decorator here, and then that produces the output. If you don't want to create an anonymous function, a one-liner function, what you can do is to actually create another function. So I'm just going to call it funct1, and I'm going to assume that it's a function that is running inside a class, and then I'm going to return what this returns. So instead of using this directly, I've created a function called funct1 to replace the lambda anonymous function. Did you see that? And with that done, I can still run my code, and you still have a result. Says go to school. Now, if it's a function that has many body, then I can do that instead of creating an anonymous function. The beauty of this is that we are actually creating this, the function will be created in whatever classes we use the word decorator in, and it doesn't have to be just one function. Here we can come and say create another function. I'm going to call it funct2, and that will take self. I'm just assuming I'm creating it directly inside the class. I'm going to return hello self. Okay, so funct2 returns self. Now to actually create the funct2 inside the class, I'm going to say CLS. That is the class that that we're decorating. I'm going to say funct, or let me just say greet. It's going to be called greet in there. And that will take in the funct2 class. So greet will be a method inside whatever class is being decorated, and that will run this. Also, say will be a method, and that will run what is in funct run. Already we have this done, where we have the word and it says go to school, and the output is Luke says go to school. The output of the method greet should say hello self, that is hello Luke. So let's do that. I'm going to print out and say p.greet. You can see hello Luke. So the two methods are existing inside, are already created inside the person class. If you take a look at the DunderDict of person, you would actually see what is happening. The DunderDict of person has greet method, and the greet method is attached to the function, the decorator function funct2, and the say method is also attached to the decorator function funct1, and that you can see in the DunderDict dictionary of person. So it's quite flexible, and basically what you're doing is just wrapping the class person inside a decorator. We can also decorate a method in a class. Instead of decorating the whole class, we can decorate a method. So let's say I have a class that I called my class, which has a dunder that takes in x, and just input an x value. I will also do a method called squared, and this method is supposed to return the square, but I will just return the x. It's actually supposed to return the square of whatever value I put here. So I'm going to use a decorator function to do that for me. So I'll call that square decor, and that takes in a function. Then I'll define a wrapper which takes in the self of the object and then returns the function, whatever the method returns, and I'm going to multiply that square it, and then I'll return the wrapper, but as a property. So just looking at these alone, if I run these and just create a my class object and put say 5 and print out the squared method, it's going to return 5 because that is what it does. Let me comment this out. I'm going to add the squared decorator on it. That is, it should decorate this squared method, and then I'm going to print out the object square. So this time I'm not going to be calling it as a method because I wanted to return it as a property. So I'm just going to be calling object squared, and as you can see here, it's returning 25 because that is what I added it. If I take this out now, you'll see it's going to return 5 because this is actually what is making it return 25, is using the decorator to square the results. So this is how you can add decorator to a method in your class.